And we're going to proceed to the next example, which says find the vertex of the quadratic function f of x equals 2x squared minus 6x plus 7. And as you can see, this is a general form and not a vertex form. The general form is the form where it's not easy to see the vertex. It doesn't come out at you as in a standard form like this. Just a reminder, this is a standard form where h and k basically in the formula, so you could clearly see your vertex coordinates there. Now, how would you approach this problem? I will show you two different methods here. So the first one is to complete a square, basically do this. Okay, convert your equation into this form. And okay, so the first step would be to isolate your term with x squared and the term with x. Okay, so bringing 7 to the other side will give me, I'm going to start here, f of x minus 7 equals 2x squared minus 6x. Okay, so now I need to complete the square, but it's kind of hard to complete the square when you have this coefficient 2 in front of x squared. So what we did in class, the examples that we did in class with completing the square, we had just x squared by itself. So we want to get rid of this 2 by basically dividing the both sides of this expression by 2, which will translate into when we separate the fractions, we're going to have everything is divided by 2. Okay. Okay, so again, in the future, I may just skip this step and go straight to that step. That's what happens when you separate the fractions out into, yeah. So what do we have now? We have f of x divided by 2 minus 7 divided by 2 equals x squared minus 3x. So now we're ready to complete the square. So basically, you're going to ask yourself, it's x plus or minus what square that will give you these two terms of a perfect quadratic expanded. Okay, and we talked about, in class, we talked about that the b is always half of this coefficient, 3. So it's going to be 3 halves negative. So it's negative 3 halves. And then here we have to add that piece of the perfect quadratic that's missing. So 3 halves squared will be 9 quarters. That's 3 halves squared. Now, I want to focus your attention on this line only. We just added a random value on the right side. I mean, it's not random. We selected a certain way that would fit our purpose, but it wasn't there before. That's the point. We just added it willy-nilly. And we cannot do that. If we did it to one side, we have to do it to the other side. Okay, so we're going to add 9 quarters to the other side of this expression. Okay, so now this becomes that. That's what we wanted. That's what we were after. And so what's happening here? Let's actually simplify it a little bit and start working backwards. So Let me rewrite it. So first, to combine 7/2 and 9/4, I need to have the same denominator. So I will multiply this by 2 and multiply the numerator by 2. Okay, the right side stays the same for now, not changing it. Okay, so here I have a 14 quarters negative plus 9/4. So that's going to be negative 5/4. Okay, so now my objective is, this is where I'm going with this. I'm going to isolate f of x again. I'm going to isolate f of x again. Yeah, so I need to bring 5/4 to the other side. So plus 5/4 plus 5/4. I'm going to continue working on this right here. So I have f of x over 2 on the left side. On the right side, it's x minus 3/2 squared plus 5/4. And the last step is to multiply everything by 2 in order to get rid of this 2 on in the denominator. So I'm multiplying the left side by 2, and because it's a fraction, I'm going to turn it into a fraction. And then or rational expression rather. And I have to multiply the right side by the same thing. So I have 2 over 1 multiplied by f of x over 2. And the 2 and 2 cancels out. And I'm going to have just f of x on this side is what I wanted. Now I'm going to distribute this 2 over 1. And here I just want to point out that I have only 2 terms inside the big parentheses. So x minus 3/2 squared group is actually considered, it's a group. It's considered just like one term. It's going to be multiplied by 2 all together as a group. Okay, so I'm going to have 2 times x minus 3/2 squared. And then I have 5/4 by itself, right? So, and it's multiplied by 2 over 1. And when we simplify, then 2 goes into 4 twice and into 2 once.
So once I simplify the right side, I'm going to have 2 times x minus 3/2 squared plus 5/2. Okay, so this is going to be my vertex form or the standard form. And from here, I can identify my coefficients. A is 2, and then H is actually the opposite. Don't forget to switch the sign here. So it's going to be positive 3/2. And K is going to be a positive 5/2. So now I know the vertex of this parabola. The vertex is 3/2 and 5/2. And, the second method that I show you, it's going to be quicker getting at the vertex. It's like we apply the formula, boom, the vertex right away. But this kind of equation gives you so much more information about your parabola. That's why I wanted to show you this method first. Well, not only tells you what the vertex is. It tells you what kind of transformations the graph went through. The base, if you start with basic x squared, you know that you have to move it, 3/2 to the right and then 5/2 up, and then you have to stretch the graph by a factor of 2 in order to obtain the graph of this function. So there's a lot of useful information here, but next I'm going to show you a shortcut.
So let's start over. So we have f of x equals 2x squared minus 6x plus 7. Okay, so basically the x coordinate of the vertex, so basically your h value, the formula goes like this: negative b over 2a. Okay, so for this one, b is -6, negative b is +6 over 2, and a is 2. So we have 6/4 or 3/4. That's your h, okay? Your x coordinate of the vertex, or h. Now, how do you find k? Well, k is basically, it's f of h, right? It's the y that corresponds to this h. If you plug this h, you get the y at that x value, and that's going to be your y value. So you just, whatever you found here, you plug it into your formula, your function. So you take 3/2 and you plug it in, and you're going to get 2 times 3/2 squared minus 6 times 3/2 plus 7. Okay, so that's 2 times 9/4 minus 6/1 times 3/2 plus 7. So what's happening here? It's 2/1, right? So 2 goes into 2 ones, into 4 twice. So here we have 9/2, and then 2 and 3. Okay, so minus a 9 plus 7. Okay, so 9/2 minus, I'm gonna combine 9 and 7. Also here I have only subtraction and addition, and I could, if this is the only thing that I have, I can actually subtract and add in any order. So I choose to combine this operation first. So I have 9/2 minus 2, and then 2 becomes 4/2, and I have 5/2. So that's my k value, or y coordinate of the vertex. So the vertex is 3/2 and 5/2. Now let's check.
So here we got our vertex of 3/2 and 5/2. Let's see if that matched our vertex that we found before. And here we are. Yes, it matched.
This one is way shorter, but it does require you to memorize another formula. Okay, so, but actually there is a shortcut to memorize this formula. It's not something new that you haven't seen before. If you recall your quadratic formula, which is the opposite of b plus or minus square root of b squared plus 4ac over 2a, does it ring a bell? This is your quadratic formula. If you eliminate the square root portion of it, you're gonna get this formula, negative b over 2a. All right, so again, it's not a new thing. It's not something that you haven't seen before. Hopefully you already memorized it here. So basically your vertex, it's very interesting because let's talk about this. So your quadratic formula gives you zeros, right, of the function. So it gives you the value for x when y equals 0. So these are your zeros of the function. And so negative, and the vertex is horizontally, it's right in between those zeros. So it is like if this is and this is the deviation of each zero in to the left and to the right of the axis of symmetry on x-axis. So when that deviation is 0, you are on the axis of symmetry, which is negative b over 2a. So that's the connection between those formulas. And the problem that I want you to try by yourself is g of x equals 13 plus x squared minus 6x. Go ahead and try it. And I'll see you in the next video.